We assume the universe had a beginning, but what if it never began? What if what we call the Big Bang is actually the internal contraction of another universe? In short, perhaps we are living inside a black hole. Today, the Big Bang, one of science's most famous theories, is being questioned. And perhaps the universe did not begin with an explosion as we thought, but with a collapse. Following recent discoveries, we will question this topic, which has become increasingly debated, with new theories and perspectives. Many textbooks describe the Big Bang as the moment the universe was born. But this is not entirely accurate. The Big Bang does not refer to a moment of creation, but rather to a process of expansion. The universe did not explode at a point and scatter matter around. There was no void to begin with. The void itself began to expand. This idea was first proposed in the 1930s by Georges Lemaitre, a Belgian physicist. He suggested that the universe expanded from an extremely dense and hot point, once called the primordial atom. A few years later, when Edwin Hubble discovered that distant galaxies were moving away from us, Lemaitre's theory was confirmed. So the universe was a tiny hot sea of energy about 13.8 billion years ago. And from that moment on, it began to expand. At least, that's what science currently accepts, though this information could change at any moment. Returning to the Big Bang, the word explosion sounds misleading. In fact, there was no explosion. There was no central point in space. Every point in space was expanding simultaneously. Imagine blowing up a balloon. When you put dots on it, as the balloon inflates, the dots move away from each other. But none of them are at the center, because everything is expanding. So in the universe, there is no such place as the point where the Big Bang occurred. Everywhere was the center at that moment. That's why every place in the universe is still within that expansion, including us. Scientists supported the Big Bang idea not only with thought, but also with observations. In 1965, two radio engineers, Arno Penzias and Robert Wilson, accidentally discovered the oldest light in the universe, the cosmic microwave background radiation. This faint microwave radiation is the heat signature of the universe when it was 380,000 years old. It's like a baby photo of the universe. This discovery became the strongest evidence for the Big Bang. Subsequent measurements showed that this radiation was nearly uniform in all directions. But there were also very small fluctuations. These small differences were the seeds of the galaxies and stars we see today. If we listen to the universe's past, it was as if a cosmic music was playing during that time. Pressure waves oscillated between light and matter, determining the structure of the universe. We can still measure the echoes of those melodies today. However, over time, some cracks appeared in the Big Bang theory. First, several additions were made to explain the early universe. Cosmic inflation, the universe expanding faster than light in its first moments. Dark matter, invisible matter that holds galaxies together. Dark energy, a mysterious force accelerating expansion. These three elements keep the theory afloat, but none of them have been directly observed yet. So our understanding of the universe depends on invisible things. Moreover, observations do not fully align with the theory. There is a problem scientists call the Hubble Tension. The expansion rate of the universe shows inconsistencies between early calculations and current measurements. So the universe is either younger than we thought or different than we thought. In recent years, the James Webb Space Telescope has sparked a new debate. This telescope, which can only see a few 100 million years after the birth of the universe, observed a period when scientists hoped to see baby galaxies. But what it saw was something entirely different. Even in the early days of the universe, there were galaxies that were much more mature, larger, and brighter than expected. This was truly surprising. Because for the universe to have reached such complex structures in such a short time, galaxies filled with stars, heavy elements, and perhaps even supermassive black holes seemed almost impossible according to existing cosmological models. At such an early stage, galaxies were expected to still be scattered, small and primitive, in the form of dust clouds. But the James Webb showed mature galaxies, as if billions of years had passed. So what does this mean? Scientists were divided. Some said, this means the universe evolved faster than we thought. Others warned, maybe we're misinterpreting the data. Because measuring the age of distant galaxies is not easy. Telescopes calculate distance, and therefore time, by looking at how much the light has shifted toward the red end of the spectrum. But this method can sometimes be misleading. It's still unclear whether some galaxies are truly that distant, meaning they belong to such an early era. Perhaps some are closer galaxies but appear farther away due to very bright gas lines. In fact, some models suggest that stars during that period could have been much larger and shorter-lived than today's stars. So the same brightness may not necessarily mean such a large galaxy. In short, what the James Webb has shown is truly extraordinary. But what if we're misunderstanding the early universe? Or what if the universe really grew? In either case, these discoveries are redefining the boundaries of the Big Bang theory. And here arises an even deeper question. What if the universe never actually expanded? This idea is not new. Some scientists have been saying for years, maybe galaxies aren't moving away from us. Their light is just aging. This idea is called the tired light theory. In other words, light may lose energy as it travels for billions of years, and we mistakenly interpret this energy loss as movement away from us. At first glance, it sounds plausible. But the problem is, if the universe isn't actually expanding, some observations can't be explained. For example, the light from distant supernovae slows down in a way that's perfectly consistent with the expansion of space. This effect, known as time dilation, is one of the most direct pieces of evidence that the universe is expanding. Furthermore, the cosmic microwave background, the universe's infant radiation, is perfectly explained by a model of an expanding and cooling universe. Similarly, the surface brightness of galaxies is decreasing exactly as it should in an expanding universe. So, while the idea that the universe isn't actually expanding sounds like an exciting alternative, it currently can't explain so much independent evidence all at once. But that's how science progresses. The more a theory is challenged, the more robust it becomes or gives way to a better one. James Webb shows us not only the distant past, but also how science has changed. Perhaps the universe grew faster than we thought. Or perhaps we haven't yet asked the right questions. But one thing is certain. Every new perspective shows that the universe is much more complex and surprising than we thought. In light of all this, another radical idea that has been put forward and sounds crazy is the black hole universe model. According to this model, our universe may actually be inside a black hole within another universe. Every black hole is like the seed of a new universe within itself. If a star is large enough and runs out of fuel, it collapses under its own gravity and eventually forms a black hole. According to classical physics, at this point, matter reaches infinite density, or singularity. But this is where quantum physics comes into play, because quantum laws state that nothing can truly be compressed into an infinitely small point. When matter can no longer be compressed beyond a certain point, it rebounds like a stretched spring, causing a jump. That jump could be the beginning of a completely different universe. So the end of one universe could mean the birth of another. Perhaps our Big Bang also originated from the internal explosion of a collapsing star within another universe. From this perspective, universes are like a chain, each born and destroyed within the other. Every black hole may be creating one of its own universe's children. We may also be in a universe born from our ancestors' universe, deep within that cosmic family tree. So the Big Bang could actually be the Big Bounce. Universes are born, expand, collapse, and are reborn. We may be part of this infinite cycle. Some physicists say this model is consistent with both Einstein's theory of general relativity and quantum physics. In other words, the birth of the universe may not be creation from nothing, but rather a cycle of continuity. The Big Bang theory remains the foundation of modern cosmology. But science never relies on absolute truths. Every new observation challenges theories. The evidence we have today is strong but incomplete. We do not fully understand how the universe began. But we know this: it will continue to surprise us.